Picture this. It's 1916, the Western Front. Millions of soldiers are dying in trenches. But there's another killer nobody talks about: shelter. Men are freezing to death in tents. Supplies are rotting in makeshift sheds. Engineers are spending weeks building wooden barracks that artillery destroys in minutes. And then one man, a mining engineer who'd never designed a building in his life, sketches a simple curved roof on a napkin. That sketch would house over 100 million people. It would survive both world wars, the Korean War, the Cold War, and everything nature could throw at it. You've probably seen one without realizing it changed history. This is the story of the Nissen Hut, the semicircular metal shelter that became the most mass-produced structure in human history, and why, over a century later, thousands are still standing.
The shelter crisis of World War I. When World War I erupted in 1914, military planners thought it would be over by Christmas. They were catastrophically wrong. What they expected to be a brief conflict of movement became a 4-year siege across Europe. And suddenly, millions of soldiers needed somewhere to live. The British Army faced an unprecedented logistical nightmare. At the war's peak, over 5 million British and Commonwealth troops were deployed across multiple fronts: France, Belgium, the Middle East, Africa, and beyond. They all needed shelter, not just for sleeping, but for hospitals, supply depots, workshops, headquarters, kitchens, ammunition storage, and everything else a modern army requires. Traditional military tents were a disaster. They leaked, they tore in strong winds, they offered no protection from artillery shrapnel. They were freezing in winter and sweltering in summer. Soldiers were literally dying from exposure while supposedly safe behind their own lines. The alternative, wooden barracks, had its own problems. They required skilled carpenters, took weeks to build, consumed enormous amounts of timber that was needed elsewhere, and were vulnerable to fire and bombardment. Worse, when armies advanced or retreated, these permanent structures had to be abandoned, wasting all that effort and material. The man nobody expected. Enter Major Peter Norman Nissen, and he was the last person you'd expect to solve this problem. Born in 1871 in the United States to Norwegian immigrants, Nissen was a mining engineer. He'd spent his career in America and Canada designing mining equipment and industrial structures. He had no formal architectural training. He'd never designed a military structure. He wasn't even originally British. He'd moved to England and joined the British Army as an engineer when war broke out. But Nissen had something more valuable than architectural credentials. He understood structural efficiency, material science, and mass production. His mining background taught him to create structures that could withstand enormous pressure with minimal material. He knew how to make things that were strong, cheap, and fast to build. In early 1916, Nissen was stationed at the Royal Engineers Experimental Station in France, where his job was to solve exactly these kinds of practical problems. He watched soldiers struggle with inadequate shelter. He saw the time and resources wasted on traditional construction, and he started sketching. The revolutionary insight. Nissen's breakthrough wasn't just a new building design. It was a fundamental rethinking of what temporary shelter could be. He asked a simple question: what's the strongest shape in nature? The answer: an arch. Arches have been used since Roman era because they're structurally efficient. The curved shape naturally distributes weight and pressure, meaning you need less material to support the same load. A curved roof sheds rain and snow automatically. There are no complex joints or angles to leak or fail. But Nissen went farther. Instead of a full dome, he designed a half-cylinder, a semicircular tunnel. This shape was even more efficient, simpler to manufacture, easier to transport, and still incredibly strong. The curved corrugated steel would act as both walls and roof, eliminating the distinction between them. The genius was in the details. The hut would be made from prefabricated curved steel panels that bolted together. No skilled labor required. Any soldier with basic training could assemble one. The panels were corrugated for extra strength and rigidity. The hut sat on a simple wooden frame and concrete foundation. Everything was modular and interchangeable. Most importantly, the design could be mass-produced. Factories could stamp out thousands of identical panels. Ships could stack them efficiently, and trucks could transport them to the front. And a small team could erect a complete hut in under 4 hours. The first test. In April 1916, Nissen built his first prototype at the Royal Engineers Experimental Station. It was 16 feet wide and could be extended to any length in 6-foot sections. The curved panels were made from corrugated iron, bolted to a wooden frame with a wooden floor and triangular end walls with doors and windows. When Nissen demonstrated his design to military officials, they were skeptical. It looked too simple, too utilitarian. It was just a curved metal tunnel. Where was the sophistication? But then they tested it. They simulated artillery vibrations. The structure held firm. They subjected it to severe weather. No leaks, no damage. They had untrained soldiers disassemble and reassemble it. They completed the task in hours. They calculated the material costs, a fraction of traditional barracks. The British Army placed an order for 100 huts, then 1,000, then tens of thousands. By 1918, Nissen huts were being manufactured at a rate of thousands per week.
Mass production revolution. To understand the impact of the Nissen Hut, you have to understand the scale of World War I logistics. This wasn't just about housing soldiers, it was about creating instant cities behind the front lines. Factories across Britain retooled to manufacture Nissen Hut components. The beauty of the design was its simplicity. Curved steel panels, straight steel ribs, bolts, and wooden end frames. That's it. No complex machinery or specialized tools required. Factories that had been making anything from ships to farm equipment could produce hut components. The standardization was revolutionary for its time. Every panel was identical and interchangeable. If a component was damaged, you could swap it out without affecting the rest of the structure. This modularity meant huts could be repaired in the field without specialized parts or skills. Transportation was equally brilliant. The curved panels could be nested together for shipping, maximizing the use of cargo space. A single railway car or truck could carry enough components for multiple complete huts. This was crucial when shipping space was at an all-time premium and German U-boats were sinking supply vessels. By the end of World War I, over 100,000 Nissen huts had been produced. They were everywhere, from the trenches of France to the deserts of Mesopotamia, from hospitals in England to supply depots in Africa. More than just shelter. What made the Nissen Hut truly revolutionary was its versatility. This wasn't just a sleeping barrack. It was a universal building system that could be adapted for almost any purpose. Need a hospital? Line the interior with wood paneling for insulation. Add windows for ventilation. Partition the space into wards. Within days, you had a field hospital that could handle dozens of patients. Need an aircraft hangar? Build a larger version with 30 or 40-foot widths, extend it as long as necessary, reinforce the doors. You now had a structure that could protect valuable aircraft from the elements. Need ammunition storage? Build it half buried in the ground for blast protection. Use it as a tunnel system. The curved shape helped deflect explosions rather than concentrating force like a rectangular building would. Need workshops, kitchens, officers' quarters, chapels, theaters, or storage? The Nissen Hut worked for all of them. Units learned to customize their huts with whatever materials were available, lining them with wood, adding insulation, building porches, installing stoves, creating windows. The hut became the Swiss Army knife of military architecture. Its very simplicity made it endlessly adaptable. The human experience. But what was it actually like to live in a Nissen hut? The answer is, it depended entirely on how much effort you put into it. In its basic form, a Nissen hut was utilitarian and uncomfortable. The curved metal walls conducted heat and cold efficiently, which meant they were freezing in winter and broiling in summer. Condensation dripped from the ceiling. The corrugated walls echoed every sound. The curved space was awkward for arranging furniture or hanging things on walls. Soldiers quickly learned to improve their accommodations. They built wooden interior walls for insulation. They constructed raised wooden floors to combat dampness. They installed stoves. The curved design actually worked well with the central stove, as heat naturally circulated around the curved walls. They created partitions for privacy. They added shelving that followed the curved walls. With these modifications, a Nissen hut could become surprisingly comfortable, warmer than a tent, drier than a trench, and far more spacious than most military accommodations. Units took pride in their huts, decorating them with whatever they could find, creating small touches of home in the midst of war. The social dynamics were unique too. A typical Nissen hut housed 20 to 30 men in close quarters. The curved space created an inherently communal atmosphere. There was no hiding in corners. This could build camaraderie or exacerbate tensions depending on the unit. Design imitators and evolution. Success breeds imitation, and the Nissen hut's effectiveness didn't go unnoticed. During World War I, other nations rushed to develop their own versions. The Americans created the Quonset Hut in 1941, essentially a refined version of the Nissen design with some improvements. The Quonset used steel framing instead of wood, had better insulation options, and featured improved ventilation. But the fundamental design, that semicircular corrugated tunnel, was pure Nissen. Peter Nissen himself continued refining his design. He patented improvements, including better ventilation systems, improved door mechanisms, and more efficient joining systems. But the basic concept, that elegant curved tunnel, remained unchanged because it was already nearly perfect for its purpose.
Peacetime transformation. When World War I ended in 1918, millions of soldiers returned home to nations facing severe housing shortages. 4 years of war had halted civilian construction, destroyed housing in combat zones, and created a demographic crisis. Young families needed homes, and needed them fast. The solution was literally sitting in fields across Europe, thousands of surplus Nissen huts. What happened next was unexpected. These military structures, designed for temporary wartime use, became permanent civilian housing. Returning soldiers, familiar with Nissen huts from their service, purchased surplus huts and directed them as homes, workshops, storage buildings, and businesses. In Britain, entire communities sprang up built primarily from Nissen huts. They appeared in back gardens as workshops, on farms as storage, in industrial areas as factories. Creative modifications transformed them, adding brick facades, building interior rooms, connecting multiple huts together, even stacking them in creative ways. The huts proved surprisingly livable with proper modification. Families added wood paneling, insulation, proper windows, chimneys for heating and interior walls. Some became charming cottages. Others served as the bones of larger structures, with additions built on to both ends. This wasn't just a British phenomenon. Across Europe, surplus military huts found second lives. In France, they became farm buildings. In Italy, temporary housing for displaced populations. In former colonies, administrative buildings and housing for remote outposts. World War II, the return.
When World War II erupted in 1939, the military world rediscovered what it had learned a generation earlier. The Nissen Hut was still the best solution for mass military shelter. Production ramped up even beyond World War I levels. Factories that had been producing civilian goods switched to churning out Nissen Hut components by the tens of thousands. The design had barely changed. Why fix what wasn't broken? This time, the scale was even more massive. The British manufactured over 100,000 huts during World War II. The American Quonset Hut variant went into production at staggering rates, over 170,000 produced during the war alone. They appeared on every front: Britain's home front for civil defense, air raid shelters and displaced persons housing; North Africa as desert outposts and supply depots; the Pacific Islands as jungle bases that could be erected in clearings; Europe during the liberation, providing instant infrastructure for advancing armies; and the Eastern Front, where both sides used curved steel hut designs. The huts evolved for new purposes. Larger variants could house tanks and aircraft. Specialized versions served as refrigerated storage units. Some were armored for ammunition storage. Others became mobile command centers, equipped with radio and communications equipment. The most innovative use came with the D-Day invasion. Engineers prefabricated thousands of huts in Britain, shipped them to France, and directed instant bases as the Allies advanced. These weren't just sleeping quarters. They were complete, forward-operating bases, with everything from hospitals to repair shops to headquarters, all in standardized Nissen huts that could be assembled by any combat engineer unit. Post-war legacy. After World War II ended, the world faced its greatest housing crisis in history. Entire cities had been destroyed. Millions of refugees needed shelter. Returning soldiers needed homes. The rebuilding would take decades. Once again, Nissen huts filled the gap. In Britain, they became emergency housing for bombed-out families. The government erected temporary communities of Nissen huts that were supposed to last 5 years. Many lasted 50, with families raising entire generations in modified huts that had long since become permanent homes. In Germany and Japan, occupying forces used Nissen and Quonset huts extensively. They became makeshift schools, hospitals, administrative offices, and housing for occupation personnel. Many remained for decades, becoming part of the local architectural landscape. Refugee camps across Europe relied heavily on the design. Displaced persons, whether from ethnic cleansing, border changes, or war destruction, found temporary and often long-term shelter in these curved steel structures. The huts found unexpected cultural significance. In Britain, the phrase "living in a Nissen hut" became shorthand for post-war austerity. Artists and writers romanticized them as symbols of resilience. Musicians used abandoned huts as rehearsal spaces. The curved walls actually provided interesting acoustics. The Cold War era. The design's utility extended through the Cold War. Military bases around the world continued using Nissen and Quonset huts well into the 1980s. They appeared at remote radar stations in the Arctic. The curved shape handled snow loads better than traditional buildings. Military bases in developing nations, quick to erect, requiring minimal skilled labor. Disaster relief operations. Agencies stockpiled hut components for rapid deployment. Research stations in Antarctica. The design proved excellent for extreme cold environments. Agricultural and industrial applications. Farmers and businesses appreciated the low cost and large interior space. The design had proven so fundamentally sound that it outlasted the empire that created it. The British Empire faded, but Nissen huts remained, standing in former colonies decades after independence. Modern survivors. Today, over a century after Nissen's original design, thousands of his huts remain in use worldwide. They've become unlikely heritage structures, with preservation societies fighting to protect historically significant examples. Some remarkable survivors include Eden Camp in North Yorkshire, where 29 original Nissen huts now house a military museum. Each hut is dedicated to a different aspect of wartime life, from the home front to Blitz experiences. RAF stations across Britain, many still have original World War II-era Nissen huts serving as storage, workshops, or offices. Some airbases operate huts that are 75-plus years old. Agricultural buildings worldwide, countless farms still use Nissen huts as barns, storage, or equipment shelters, often unaware of their historical significance. The huts have achieved a certain retro-cool status. Architects study them as examples of efficient design. Survivalists and off-grid enthusiasts build modern versions. Music venues preserve them for their unique acoustics. Artists convert them into studios and galleries.
So what made the Nissen Hut so successful? Why did this simple design outlast virtually every other military structure of its era? The answer lies in its engineering elegance. Structural efficiency. The semicircular arch is one of nature's strongest shapes. The curved form distributes loads evenly, meaning the structure can support tremendous weight with minimal material. Unlike a flat roof that must resist gravity, the arch converts vertical forces into compression forces along the curve, and corrugated steel handles compression beautifully. Material minimalism. A Nissen hut uses remarkably little material for the space it encloses. No internal supports are needed. The curved skin is self-supporting. Compare this to a rectangular building of the same size, which requires walls, roof trusses, beams, and supports. The Nissen hut eliminates most of that. Aerodynamic form. The curved shape sheds wind naturally, reducing wind loading. It also sheds rain and snow automatically. No flat surfaces for water to pool or snow to accumulate. This passive weatherproofing is incredibly valuable in military situations where maintenance may be impossible. Modular construction. Every component is standardized and interchangeable. Panels bolt together with simple connections. There are no complex joints or custom pieces. This means unskilled labor can assemble them. Repairs are straightforward, and damaged components can be swapped out easily. Transportability. The nested panels ship efficiently. A truck could carry components for multiple huts. This maximized scarce transportation resources, crucial in wartime logistics. Scalability. The basic design could be shrunk or expanded. Need a small storage shed? Build it 16 feet wide. Need an aircraft hangar? Build it 40 feet wide. Need more length? Just add more curved sections. This universality meant you didn't need different designs for different purposes. Lessons for modern design. The Nissen Hut offers profound lessons for contemporary architecture and engineering, many of which have been forgotten in our age of computer-designed complexity. Function over form. Nissen didn't try to make his hut beautiful. He made it work. The aesthetic emerged naturally from the functional requirements. This purity of purpose created a design that, ironically, many now find attractive in its simplicity. Appropriate technology. The hut used available materials and manufacturing techniques. It didn't require advanced technology or specialized tools. This made it accessible and practical in contexts where fancy solutions would fail. Design for assembly. Modern flat-pack furniture owes a debt to the Nissen Hut's approach. Everything was designed to be easily assembled with minimal tools and skills. The user experience of construction was part of the design. Durability through simplicity. With fewer components and joints, there were fewer points of failure. The curved steel skin was inherently resistant to damage. Simple structures tend to outlast complex ones. Adaptability. The most successful designs can be repurposed. Nissen couldn't have predicted all the uses for his hut, but its simplicity allowed users to adapt it to countless purposes. Contemporary architects studying sustainability increasingly look to designs like the Nissen Hut. It was recyclable. Steel could be melted down and reused. It was energy efficient in manufacturing, simple stamping operations. It had a low carbon footprint for the space provided. It could be disassembled and moved rather than demolished. The human factor. Perhaps the most important lesson is this: the best design serves human needs first. Nissen didn't set out to create an architectural icon. He saw soldiers suffering from inadequate shelter and applied practical engineering to solve their problem. His design succeeded because it addressed real human needs: protection from weather, quick deployment, ease of use, adaptability, and psychological comfort through enclosed space. The hut's durability stemmed not just from engineering, but from human attachment. People took ownership of their Nissen huts, improving and personalizing them. This investment, both practical and emotional, ensured the structures were maintained and valued. In a world obsessed with high-tech solutions and architectural statements, the Nissen Hut reminds us that sometimes the best answer is the simplest one. Not the cheapest, not the fanciest, but the one that does exactly what's needed with minimum waste and maximum efficiency. Peter Nissen's legacy. Peter Nissen received relatively little recognition for his revolutionary design. He was awarded the Distinguished Service Order for his military contributions, and his patent earned him some royalties, but he never became wealthy or particularly famous. He died in 1930 at age 59, just 14 years after inventing the hut. He couldn't have known that it would be in use nearly a century later, that it would house over 100 million people during its lifetime, and that it would fundamentally change how we think about temporary structures. The Nissen Hut stands as a monument to practical genius, the kind of innovation that doesn't seek glory, but simply solves problems elegantly. It proved that the best designs often come from unexpected sources, that simplicity can be more revolutionary than complexity, and that good engineering is timeless. Over a century later, those curved steel tunnels still stand around the world, rusting perhaps, repurposed definitely, but enduring. They're no longer temporary shelters waiting to be replaced. They're permanent testaments to the power of thinking differently about ordinary problems. The next time you see one, and now that you know what to look for, you'll start noticing them everywhere. Take a moment to appreciate what it represents. That simple curved roof changed history, sheltered millions, and proved that sometimes the greatest innovations are the ones that quietly work, decade after decade, without fanfare or fuss. That's the legacy of the unbreakable hut.
Thank you for joining me on this journey through the surprising history of the Nissen Hut. If you enjoyed learning about this overlooked innovation, let me know what other forgotten technologies or designs you'd like me to explore. Don't forget to like and subscribe for more stories about the simple ideas that change the world. Until next time, remember, the best solutions are often the ones we stop noticing because they work so well.